Okay, so our next speaker, we're going to take a real, more coarse, distant look at fire from kind of a satellite image and look at a large-scale fire perspective. And Dave is with USDA Forest Service Rocky Mountain Research Station, but he's based in Reno, unlike Stan's based in Provo, Utah. So, Dave, thank you.
All right. So I am going to be talking at a much larger scale. And as everyone knows, there's just a general pattern of increased burn throughout the entire West. Denison's found this. We can see most of the work has been occurring in forested ecosystems, although there's some work going into sagebrush ecosystems. And what has been happening in PJ systems is limited, and the work that has occurred has been typically at a much more local scale. So what I did was I looked at the Piñon Juniper range maps, outlined that with the Type 3 EPA ecoregions, and selected those out, and then created 4 regions: the Northern Intermountain region, the Southern Intermountain region, the Central Rocky Mountain region, and the Southern Rocky Mountain region. I then overlaid the Piñon Juniper land cover types from the REGAP analysis. As you can see, this basically creates really large classifications. So most of the Northern Intermountain region has intermountain basins juniper savanna and doesn't have much else. So it kind of lumps all the savanna to woodland variation into one category. The Northern Intermountain region had very little Piñon Juniper land cover type, less than 5%, at 5%. And you went all the way up to the Central Rocky Mountains, which was in around 20, the Southern Rocky Mountains, which was in around 23%. I then also overlaid the large wildfire MTBS data onto this. In this case, most of the fire is occurring in the Northern Intermountain region, and the least amount of fire is occurring in the Central Rocky Mountain regions. We also have a temporal pattern in this, in that you can look in the Central Rocky Mountains and there's much more of a spring component to the fires as opposed to the Northern Intermountain region. Okay, so if we look at what PJ is doing in this system, it's basically following along with the large fires. You have, in the Northern Intermountain region, about 15% of the total region is being burned, and about 13% of the Piñon Juniper in that region is also being burned. You go down to the Central Rocky Mountains, and we've got fire at 2%, and PJ is maybe a little bit more at 3%. So, like Rick mentioned, he's really interested in fire because it's a big component of the Piñon Juniper there. Someone down in the Central Rocky Mountains, maybe they're not as interested in fire because it's not as large of a component. However, if you flip that perspective and look at it from a burn perspective, someone that's studying fire in the Northern Intermountain region may have some interest in Piñon Juniper, but may not be that interested in Piñon Juniper because Piñon Juniper is less than 5% of the total area burned. And while in the Central Rocky Mountains, if you're looking at fire, you may be very interested in fire on Piñon Juniper because it has almost 23% of the area burned. So there's a little bit of a flip in this and the way you look at this, and it depends on where you're coming from as to whether Piñon and Juniper is important in fire. And then putting those two graphs together, you find that in the Southern Intermountain region, Piñon Juniper is actually, burned Piñon Juniper is has the largest amount. It just burned the most Piñon and Juniper in that region. It was it was a little bit like 1% of the region. And these are pretty large regions, so that's not that small number is not that big of a deal. One quick note on this is that In the southern Rocky Mountain region and the central Rocky Mountain region, you have some differences in the proportion of the region of how much PJ is in the system and how much the burn is in the PJ. So for example, in the southern Rocky Mountain region, you have about 23% Piñon Juniper land cover types, but you have less, about 13% of the burn area is PJ. So PJ is burning a little bit less than expected in that region. In the central Rocky Mountain, you have the flip. You have about 13% PJ in the system, and it's burning at about 20%. So the PJ is burning a little bit more than expected for the entire region. Okay. However, fire in general is going much more prevalent in the northern Intermountain region, much less present in the central Rocky Mountains, with intermediate levels at the other two regions. Number of fires is highest in the northern Rockies, lowest in the central Rockies. The rate of fires within the fire season, if I scale that to the level of the region, that's most strongest at the northern Intermountain region, lowest in the central Rockies. Fire size, median fire size, they're largest in the northern Intermountain region, lowest in the central. Maximum fire size, same story. So regionally, this can probably be dealt with a lot with climate and what climate has created as far as vegetation. In the western geographic regions, so that's the Intermountain regions, we have a high proportion. Those are flipped. In the eastern geographic regions, we have a high proportion of winter precipitation. In the western geographic regions, we have a low proportion of winter precipitation. Sorry. That meant that there's more shrubs, less grasses and forbs. The more fires that are burning in the months of July and August, and the fire spread is larger and more intense in those regions because you have potential for greater fire weather. In the eastern geographic regions, it receives more summer precipitation, has a greater component of P&G, that's my acronym for perennial native grasses and perennial native forbs. There's more fire prior to the onset of summer precipitation in June, and the fewer fires overall, especially during the summer months. Okay, fire rotations, they're basically within the parameters that everyone else has looked at. 240 years for the northern Intermountain region for woodland types, 802 years in the central Rocky Mountain region. So that's basically, because it's basically the same numbers flipped, the same pattern is occurring. One note, when I took calculated the fire rotation based on only the last 15 years, we saw a decrease in the fire rotation, so fires are occurring more frequently. And actually, that is what I'm going to be going through on the next set of slides, the change in fire pattern from 1984 to 2013. I basically used a Tau Kindle statistic to look at whether there was a trend in changes in our fire statistics. If we look at total area burned on an annual basis, in the northern Intermountain region, we have no significant increase in total fire area burned. Visually, there is a sense of it. However, I think that is primarily due to a couple very large years. However, Piñon Juniper has increased. And the next number there is a rate. That rate, of course, had to change if Piñon Juniper increased, but the total didn't increase. The rate of Piñon Juniper within the total area burned has to have increased. Southern Intermountain region, I had no significant increase in total fire area. That's basically a flat line for that period. The Southern Rocky Mountain region, we had an increase in total area. We had an increase in PJ, but we did not have an increase in rate. There's median rate of 13% PJ on an annual basis. That was true in 1984, and that's also true in 2015. So basically, PJ is going along for the ride. We're increasing the total fire, but PJ is increasing at the same rate. Central Rocky Mountain region, there's no increase in fire. PJ does appear to be increasing, and of course that rate is increasing if you don't have a total increase. Number of fires annually, nothing. There's not any indication of fires increasing over time. There is some indication of some periodicity in that number, which would mask the tallow kindle statistics' ability to see any trends because of the way that statistic is calculated. That being said, anything that is there is pretty squinty. You can maybe see it if you close your eyes and make it really blurry, but it's not very strong. If we do look at fire season, that is also not making much change, but that's not a surprise. If you're not changing numbers, fire season is not going to be changing, because if you increase the fire season, you would expect to see more fires. So the northern Intermountain region, once again, not significant. The southern Intermountain region had an earlier start and a later end date. Those are pretty low. They're 0.03 and 0.02. The season length was not significant. That was at a 0.07, if I remember right. So that's sitting at the marginally significant level. So that's probably, you can either take that as there's a sign, or you can take that as statistical fluke. Southern Rocky Mountain region also had basically the same story, just flipped. Neither the start nor the end date had a significant change, but there was an increase in the total length. Once again, these numbers are at 0.03 to 0.07, so you're not looking at a large, significant, highly significant value. So given the number of times I've rolled the dice, I may have hit the two spots that were significant or off. Central Rocky Mountain region, once again, had no significant change in season. Median fire size, the only location that actually, region that showed an increase in the median fire size was in the Southern Rocky Mountain region. In the Southern Rocky Mountain region, I looked at fire size at both the median fire size, at first quartile, third quartile, and at the maximum. None of the other areas showed any increase in any of the quartiles except for the maximum, although Southern Rocky Mountain did. So the first quartile was significantly increased, so was the third quartile, and so was the maximum. That indicates for me that the Southern Rocky Mountain region has actually changed its fire size distribution. However, the Northern Intermountain and the Southern Intermountain region had an increase in maximum fire size. That means that the tail of that distribution is going up. That means that these large fire events in those two regions are becoming much more common, but we're still basically within the same fire regime. So there's no change in the fire size in general. Okay. So what's causing these increases in fire, total area burned, and PJ burned? Some of this is probably related to CO2, as Rick mentioned, that increases plant growth during favorable growth periods in both fine and woody fuels. We can get increases in invasive annual grasses in the northern Intermountain and northern portion of the southern Intermountain. Also the Colorado Plateau, where in some areas there appears to be a net decline in PJ types due to increases in introduced annual grasses. We also have landscape change in fire. Woodland expansion beginning in the mid-1800s, as Stan just went through. Favorable establishment conditions, active fire prediction after 1930. Changes in the Piñon Juniper land cover type over time, and the early and late encroachment decreased fine fuels, so you get fewer and smaller fires. Late encroachment and more crown fires, larger and more severe fires. The landscape tree cover is increasing at 10%, 2 to 6-fold increase since 1860, and the canopy closure in the next 50 years. So to wrap this up, the magnitude of fire vary among the regions, and trends but the trends were more or less consistent in that the northern Intermountain region had less fire and this had more fire, and the central Rocky Mountain region had less fire. The PJ types not burning less frequently than the other types, with some nuances within the southern Rocky Mountain region and the central Rocky Mountain region. Fire rotations are more or less the same as what the small-scale studies have concluded. Increases in Piñon Junior type burned area over time. We need to take careful monitoring of long-term trends in fire activity and the interacting effects of invasive annual grasses, bark beetle, climate change is needed to access vulnerability of Piñon and Juniper land cover types. Understanding the longer-term ecosystem trends and the primary drivers of the different regions can help inform desirability of management treatments to remove Piñon and Juniper and improve habitat. All right. And does anyone have any questions? Oh, Stan.
It appeared to me that your changes in pattern of fire were more, where there was some evidence where that tended to be more to the south and less to the north. Did I capture that correctly? Where there was change?
Yeah. So so the question is, was the pattern of less change in the north and more change in the south? And that is something that I would agree with, that especially because the change in the southern Rock, and well, I shouldn't say the south, I should say the southern Rocky Mountain region. Central Rocky Mountain region was fairly less. That change in the southern Rocky Mountains showed a change in fire size throughout the entire, also showed some changes in season. And the southern Intermountain, which is also a southern region, that one also showed an increase in the tail of the distribution, as well as the slight changes in the season. So I would agree that it's the southern region that's showing more change. Thanks.